नमस्कार विद्यार्थी मित्रांनो, आपण मागच्या लेक्चरमध्ये डेफिनाइट इंटिग्रेशनला सुरुवात केली आहे. वी हॅव सीन द फंडामेंटल थिअरम ऑफ इंटिग्रल कॅल्क्युलस which says if integration of f of x is g of x, if integration of function f of x is g of x, then definite integration of f of x from limit a to b is g of b minus g of a. So if we want to evaluate this integral, its limits are from 0 to pi by 4 and integrand is root of 1 plus sine 2x. So according to fundamental theorem of integral calculus, first we have to find integration of this function, and in that integration, if its integral is g of x, we find g of pi by 4 and g of 0 and take difference. म्हणजे पहिल्यांदा इंटिग्रेशन काढणं आवश्यक आहे. So for finding integration, we denote this integral by I, and in place of 1 let us write cos square x plus sin square x. In place of 1 we write cos square x plus sin square x. So this is a complete square of cos x plus sin x. Cos x plus sin x bracket square, and its square root. Its square root is cos x plus sin x. Limits are from 0 to pi by 4. Now we write integration of cos x. Integration of cos x is sin x, and integration of sin x is minus cos x between limit 0 to pi by 4. So we evaluate this. This is g of x. This is g of x. We evaluate this expression by taking x is equal to pi by 4. Then we evaluate same expression by taking x is equal to 0 and subtract this second answer from the first one. So sin pi by 4 is 1 by root 2, cos pi by 4 is 1 by root 2. So this 1 by root 2, 1 by root 2 will get cancelled. Sin 0 is 0 and cos 0 is 1. This minus sign gets distributed here. So answer is 1. So integration of this function between limits 0 to pi by 4 comes to be 1. So for these elementary problems, we don't have to do anything else. We have to just integrate it and use the formula g of b minus g of a. Here is one more sum. To evaluate this integral between limit 0 to 4 of 1 upon root of 4x minus x square, our first aim is to find integration of this function. म्हणजे indefinite integration मध्ये जसं इंटिग्रेशन काढतो तसं हे इंटिग्रेशन आपल्याला काढावं लागेल. Now what I will do, I will make it complete square, complete quadratic, पूर्ण वर्ग करायचे. त्याकरता मला इथं -4 लागेल. So I will add and subtract 4. Add and subtract 4. तो ॲड केलेला 4 इथं दिसतोय, सबट्रॅक्ट केलेला 4 मी इथे वापरलेला आहे. I have taken minus sign common from these three terms. This is x minus 2 square. So I write this as 1 upon root of 4 minus x minus 2 square. I rewrite this as x minus 2 square. And integrate it. Its integral is 1 upon root of a square minus x square, a square minus u square, say. So its integral is sine inverse u upon a. A is 2. This 4 is 2 square. So sine inverse of x minus 2 upon 2. Now we have to first put x is equal to 4 and evaluate this expression. Then put x is equal to 0 and then again evaluate this expression. So when I put x is equal to 4, it is 4 minus 2, 2. 2 upon 2 is 1. So this becomes sine inverse 1. And when I put x is equal to 0, this becomes sine inverse minus 1. Sine inverse of minus x is minus sine inverse x. That sign will come out and it will become sine inverse 1 plus sine inverse 1. Sine inverse 1 is pi by 2. So 2 times pi by 2, that is pi. So integration of this function between limit 0 to 4 comes to be pi. And for evaluating this, we first evaluate this plane integral by doing little adjustment. Okay. Now let us move to next sum. integration of sine raised to 4x, integration of sine raised to 4x between limits 0 to pi by 4. For this, what we do? We write this, make use of the formula 2 sine square theta is equal to 1 minus cos 2 theta. And for that I want 2 here. So I have adjusted 1 by 4, and inside 4 I write that 4 as 2 square. हे थोडी ॲडजस्टमेंट केलेली आहे आणि ह्या ॲडजस्टमेंट नंतर मी ह्या 2 साइन स्क्वेअर एक्सला 1 मायनस कॉस 2x असं लिहिणार आहे. आपल्याला ज्यावेळेला साइन एक्स कॉस एक्स यांचे इंडेक्स असतात, पॉवर असतात, ते पॉवर कमी करायची. हो, त्याचे पॉवर, त्याचा इंडेक्स, एक्सपोनंट जो आहे, we have to reduce that exponent, reduce that index, and for that we have to use formula 2 sin square theta is equal to 1 minus cos theta. If it is cos square x, we have 2 cos square x is equal to 1 plus cos 2x. So here I use formula for 2 sin square x as 1 minus cos 2x, bracket square. Everything else is as it is. Now we expand this. याला आपण एक्सपांड करणार. 1 minus cos 2x square, 1 square 1, this cos 2x square इथे cos square 2x, and twice their product minus 2 cos 2x हे इथं लिहिलेलं आहे. आता याला डिस्ट्रीब्यूट करून घेतो. खरं तर हा cos square 2x आहे ना, ह्याच्यामध्ये अजूनही याला इंडेक्स आहे, डिग्री आहे 2. त्याला रिड्यूस करण्यासाठी मी cos square theta इज इक्वल टू 1 प्लस कॉस 2 थीटा हा फॉर्म्युला वापरणार आहे. हा फॉर्म्युला मी इथं वापरणार आहे. 2 cos square theta is equal to, so I adjust 2, and in place of 2 cos square 2x I read as 1 plus cos 4x. आता थीटाची व्हॅल्यू 2x आहे, त्याच्यात डबल अँगल इथं येणार. याला डबल अँगल फॉर्म्युला म्हणतात. तर ह्या डबल अँगल फॉर्म्युल्याने मी याला सिम्प्लिफाय करून घेतलेला आहे. तीच स्टेप मी इकडे लिहिलेली आहे. फक्त यातला जो 1/2 होता तो 1/2 आपण बाहेर आणलेला आहे, त्याचा 1/8 झालेला आहे. अँड वी मस्ट मल्टिप्लाय दिस 1, दिस 2 बाय दिस 2. आपण ज्यावेळेला हा कॉमन घेतो त्यावेळेला याच्यामध्ये नाही आहे, सो वी मस्ट मल्टिप्लाय दिस 2 टर्म्स बाय 2. ओके, नाउ आफ्टर doing this little adjustment, now is the time. This is called simplification. After doing this simplification, now is the time to take actual integral. So I will take integration of 2, but before taking integration of 2, let me add this 1 and 2. These are two constants. And now I will write integration of 3. Integration of 3 is 3x. Integration of cos u is sin u. Integration of cos u is sin u. So here I made a mistake in writing integration. I have written this cos 2x as it is, but actual integration of cos 2x is sin 2x. So this should be sin 2x. Sin 2x upon 2, that coefficient. Then integration of cos 4x is sin 4x. It should be sin 4x upon 4. Sin 4x upon 4. And then its limits are 0 to pi by 4. Its limits are from 0 to pi by 4. First we evaluate this whole expression by taking x is equal to pi by 4. And then evaluate this expression 3x minus 4 by 2 into sin 2x plus 1 by 4 into sin 4x. We evaluate this expression by taking x is equal to 0 second time. First time evaluate it by taking x is equal to pi by 4, and then by taking x is equal to 0 and subtract. तर हे simplification करून 2 to the 4 आणि sin 2x पाहिजे इथं. अगेन आय मेड मिस्टेक हिअर ऑल्सो इन दिस स्टेप ऑल्सो. दिस शुड बी sin 2 times pi by 4. sin 2 times pi by 4. हा पाय नाही आहे, इट शुड बी pi by 4. तर हे कॅल्क्युलेशन जे आहेत हे कॅल्क्युलेशन्स चुकीचे आहेत. दिस कॅल्क्युलेशन्स आर रॉंग. सो आय विल स्किप दिस स्लाइड. म्हणजे मी इथपर्यंतच फक्त तुम्हाला सांगतो. ही पण स्टेप कट करूया आपण. नाव आय विल एक्सप्लेन दिस प्रॉब्लेम लाईक दिस. नाव आफ्टर दिस स्टेप we evaluate this integral, and in that integral we take x is equal to pi by 4, take x is equal to 0, and take difference of those two answers. Now I will move to my next question. This is the next question. Actually this is new type. म्हणजे आत्तापर्यंत आपण जे प्रॉब्लेम केलेले आहेत 10 प्रॉब्लेम मी तुम्हाला सांगितलेले आहेत. ह्या 10 प्रॉब्लेममध्ये आपण एकच मेथड, एकच फॉर्म्युला, एकच टेक्निक वापरत होतो. अँड दॅट टेक्निक वॉज जस्ट टू इव्हॅल्युएट दॅट इंटिग्रल अँड मेक use of the formula g of b minus g of a to find numerical answer. Now in the second type we observe that problems cannot be evaluated, integrals cannot be evaluated easily. We have to make method of substitution. We have to make use of method of substitution. But while using method of substitution, one has to change the limits also. These limits are values of x. So x is equal to 0 to x is equal to pi by 4. That means lower limit of x is 0 and upper limit of x is pi by 4. So when integration cannot be evaluated directly, when we have to make use of method of substitution, one has to change limits also. So I will explain how to change limits using this example. In this problem, I will put tan x is equal to t. I put tan x is equal to t. When I put tan x is equal to t, I have to find value of dx also in terms of dt. So for that, I differentiate this both sides of this equation and write sec square x dx is equal to dt. And write sec square x dx is equal to dt. So this sec square x dx will become dt, and in place of tan x, I will write t. But what about the limits? These 0 and pi by 4 are values of x. 0 and pi by 4 are values of x. I must find corresponding values of t. Corresponding values of t. So I take x is equal to 0. I write when x is equal to 0, what will be the value of t? When x is equal to 0, t is equal to tan 0. And tan 0 is equal to 0. So I write when x is equal to 0, t is equal to 0. Now, when x is equal to pi by 4, when x is equal to pi by 4, t will be equal to tan pi by 4. Tan pi by 4 is 1. So I write when x is equal to pi by 4, t is equal to 1. So when I will write this integral in the language of t, using variable t, I must use limits of t. Means lower limit of integral will be 0. Fortunately it was 0. And upper limit will be 1. So I write this integral as integration from 0 to 1. Not 0 to pi by 4 now. 0 to 1. 1 upon this dx, sec square x dx becomes dt. So 1 upon 3t square plus 4t plus 1. I am writing tan x is equal to t. Okay. Now, there are two ways. One way is make this coefficient of t square to be perfect square. In that case, one has to multiply numerator and denominator by 3. So this will become 9t square. Or alternatively, you can take out this 3. 3 हा तुम्ही कॉमन घेऊ शकता संपूर्ण एक्सप्रेशन मधून. So here 3 is taken out, taken common, and after that we make it complete quadratic. पूर्ण वर्ग करणार. त्याकरता आपल्याला लास्ट टर्म शोधायला लागते. लास्ट टर्म कॅन बी ऑब्टेन बाय फॉर्म्युला मिडल टर्म स्क्वेअर अपॉन 4 into फर्स्ट टर्म. मिडल टर्म स्क्वेअर अपॉन 4 into फर्स्ट टर्म. that gives me last term, suitable convenient last term is 4 by 9. So I will add and subtract that 4 by 9. 4 by 9 ही टर्म मी ॲड आणि सबट्रॅक्ट केलेली आहे. मग हे जे एक्सप्रेशन आहे ते होतं कम्प्लीट क्वाड्रेटिक पूर्ण वर्ग. इट इज स्क्वेअर ऑफ टी प्लस 2/3 and this minus 4/9 plus 1/3 becomes minus 1/9. Their sum is minus 1/9. So this integral is of the type 1 upon u square minus a square. 1 upon u square minus a square. Its integral is 1 upon 2a into log of u minus a upon u plus a. So we write this as 1 upon 3, this 1 upon 3 as it is. For 1 upon 2a, a is equal to 1 by 3. This 1 by 9 means 1 by 3 square. So 1 upon 2a, formula मध्ये आहे 1 upon 2a log of u minus a upon u plus a. Now we multiply by 3 to numerator and denominator, simplify this and make use of the new limits, means limits of t, limits of this new integral are 0 and 1. So in this expression put t is equal to 1, means 3 plus 1 4. Actually this should be minus, हे minus असायला पाहिजे, this is minus. 1 minute, no, it is plus, how it is plus? This 2 minus 1 is 1, so it is 1 by 3, plus as I think. So put t is equal to 1, 3 plus 1 4 by 6, and when we put t is equal to 0, this will be 1 by 3. t 0 घेतल्यानंतर हा व्हॅनिश होतो, तर हा 4 by 6 आणि हा 1 by 3. Now we use formula log c minus log d is equal to log c upon d. Log c minus log d is log c upon d. त्या फॉर्म्युलाने सिम्प्लिफाय केलं, तर हाफ log 2 is answer to this question. तर हा अशा पद्धतीने आपण सिम्प्लिफाय करून इव्हॅल्युएट केलेला आहे. मेथड ऑफ सबस्टिट्यूशनचा वापर केलेला आहे. पुढच्या क्वेश्चनकडे वळतोय. मी आणखी काही प्रॉब्लेम तुम्हाला सबस्टिट्यूशन मेथडने करून दाखवणार आहे. 2 ते 3 प्रॉब्लेम. कसं ओळखायचं की हा प्रॉब्लेम सबस्टिट्यूशनने करायचं? इझिली हे आहे, सरळ इंटिग्रेट करून पहा. होत असेल तर ठीक आहे, नसेल तर आपण एक म्हण वापरतो, टेढ़ी उंगली से घी निकलता नहीं तो उंगली, टेढ़ी उंगली से घी निकलता नहीं अगर तो उंगली सीधी करनी पड़ती है. तो अगर इजीली आसानी से वो प्रॉब्लम नहीं हो सकता तो उसके लिए आपको सब्स्टिट्यूशन करना जरूरी है. जर आपल्याला सहजपणे हा इंटिग्रेट होत नसेल तर आपल्याला सब्स्टिट्यूशन करावंच लागेल. So we put sin for this problem, this is linear in sin x and cos x. When it is linear in sin x and cos x, we have one standard substitution. That standard substitution is, do you remember what is that standard substitution? Yes, that standard substitution is put tan x by 2 is equal to t. Put tan x by 2 is equal to t. When tan x by 2 is equal to t, this dx becomes 2 upon 1 plus t square into dt, or sometimes we read this as 2 dt upon 1 plus t square. This is the value of dx. What is value of sin x? Sin x is 2t upon 1 plus t square and cos x is 1 minus t square upon 1 plus t square. ज्यावेळी मी तुम्हाला मेथड ऑफ सबस्टिट्यूशन शिकवलेली आहे त्याच्यामध्ये हे सबस्टिट्यूशन केल्यानंतर हे चेंजेस होतात हे शिकवलेलं आहे. गरज पडली तर तो व्हिडिओ तुम्ही परत पाहू शकता, पुस्तक उघडू शकता की हे tan x by 2 is equal to t असेल तर dx ची व्हॅल्यू ही कशी येते, sin x हा कसा येतो, cos x हा कसा येतो. आता आपल्याला लिमिट्स काढायला लागतील. लिमिट्स t चे काढायचे. मग t चे लिमिट काढताना x is equal to 0 घेऊन याला इव्हॅल्युएट करा. when x is equal to 0, t is equal to tan 0. tan 0 is 0. Therefore when x is equal to t, x is equal to 0, t is equal to also 0. So lower limit of new integral will be 0. Now what will be the upper limit of new integral? For that we put x is equal to pi. X is equal to pi. So this becomes tan pi by 2. But tan pi by 2 we write it as infinity. Actually it is not defined, but for convenience we denote it by this symbol. Tan pi by 2 we denote by infinity. So lower upper limit will be infinity. So we rewrite this integral. हे जे इंटिग्रल आहे हे इंटिग्रल मी टीच्या लँग्वेजमध्ये लिहितो. I is equal to integration from 0 to infinity 1 upon this 3 as it is, 2 as it is, sin x. For sin x I write 2t upon 1 plus t square. For sin x I write 2t upon 1 plus t square इथे. आणि for cos x, in place of cos x I write 1 minus t square upon 1 plus t square. For dx we have 2 dt upon 1 plus t square. Now we take LCM of this expression. In this expression we take LCM, and after taking LCM, this 3 is to be multiplied by 1 plus t square. This 1 plus t square will get cancelled with that LCM 1 plus t square. Okay, so this 3 into 1 plus t square gives me 3 plus 3t square. This 2 to the 4t square. 4t. And this 1 minus t square as it is. Okay, so this 3t square minus t square, their sum is 2t square. Their sum is 2t square. This 3 plus 1, their sum is 4. So 2t square plus 4t plus 4. We can take 2 common. And that will get cancelled with this 2. म्हणजे तो 2 आपण याच्या बरोबर कॅन्सल केला. So this expression becomes t square plus 2t plus 2. We want to make it complete quadratic, and for that we want suitable constant, and suitable constant here is 1. Suitable constant is 1. So we have to just split these 2 as 1 plus 1. So this t square plus 2t plus 1, it is t plus 1 square. So our integral will change into 1 upon t plus 1 square plus 1 square. It is of the type 1 upon x square plus a square. 1 upon x square plus a square. Now I can integrate it. 1 upon x square plus a square. We can read it as 1 upon 1 plus x square, and its integral is tan inverse x upon a. So this is tan inverse t plus 1 upon 1. Now evaluate this integral by taking t is equal to infinity. So when I read t is equal to infinity, this is tan inverse infinity minus tan inverse 1. When I take a t is equal to 0. Tan inverse infinity is pi by 2 and tan inverse 1 is pi by 4. Their difference is pi by 4. So pi by 4 is answer to this question. Let us discuss one more question by method of substitution. ह्या मेथड ऑफ सबस्टिट्यूशनने आपण आणखी एक प्रॉब्लेम करणार आहोत. हा आहे तो प्रॉब्लेम. इंटिग्रेशन ऑफ 1 अपॉन a square into e raised to x plus b square into e raised to minus x between limits -1 to 1. Integration from -1 to 1 of 1 upon a square into e raised to x plus b square into e raised to minus x. Now, first we make little simplification, and that simplification is we multiply numerator and denominator of this integral by e raised to x. म्हणजे हा e raised to minus x into e raised to x, that will become 1. This e raised to x when multiplied by e raised to x will become e raised to 2x or e raised to x square. e raised to x चा स्क्वेअर म्हणजेच e raised to 2x. आता याच्यामध्ये सबस्टिट्यूशन करायचं आहे. वी सबस्टिट्यूट e raised to x is equal to t. Differentiate this. Its derivative is e raised to x dx is equal to dt. So this e raised to x dx will become dt. This is a square e raised to x square ई रेज टू एक्सचा स्क्वेअर आहे म्हणजे हा टी स्क्वेअर होईल आणि हा बी स्क्वेअर होईल. सो आवर न्यू इंटिग्रल, before going to new integral, let me talk about limits. What will be the new limits? So to find new limits, I take x is equal to -1 and put it here. X is equal to -1. So t is equal to e raised to -1. That I can read as 1 upon e. So this will be the lower limit. 1 upon e will be the lower limit. And when I put x is equal to 1 in this integral, x is equal to 1 in this substitution, I get t is equal to e. So e will be the upper limit. So in new integral, lower limit will be 1 upon e and upper limit, lower limit will be 1 upon e and upper limit will be e. These are limits of t. These are values of t. And we write this integral in the language of t. We are substituting e raised to x is equal to t. So this becomes 1 upon a square t square plus b square. Take a square common and it will change in the form 1 upon x square plus a square. It will take the form 1 upon x square plus a square. Its integral is tan inverse x upon a. Tan inverse x upon a. So 1 upon a into tan inverse x upon a. 1 upon a into tan inverse x upon a. Here b upon a is playing the role of a. त्याकरता हा b upon a इथं आलेला आहे. Now evaluate this between limits 1 upon e to e, means put t is equal to e and then t is equal to 1 upon e and simplify this and then simplify this. So these are the simplifications. You can check and we cannot further simplify this. This is tan inverse. This is tan inverse. हे जे आहे हे tan inverse आहे, पायापाशी दिला गेला आहे. This is tan inverse and this is the final answer. We cannot further simplify this integral. Okay. Now I will stop my today's lecture here with this problem. आपण आज इथं थांबतोय. मेथड ऑफ सबस्टिट्यूशन झालेली आहे. यानंतर आणखी 2 प्रॉब्लेम माझ्याकडे आहेत मेथड ऑफ सबस्टिट्यूशनचे. तर ते प्रॉब्लेम जस्ट आपण पाहूयात. हा आहे x इंटू टॅन इनवर्स एक्स. एक्स इंटू टॅन इनवर्स एक्स याला सबस्टिट्यूशन नाही केलं, त्याला बाय पार्ट्सने इंटिग्रेट केलेलं आहे. मी पुढच्या लेक्चरमध्ये हा प्रॉब्लेम एक्सप्लेन करेल तुम्हाला. प्रत्येक वेळी फक्त सबस्टिट्यूशनच करावं असं नाही. आपल्याकडं वेगवेगळ्या 4 ते 5 मेथड आहेत इंटिग्रेट करण्यासाठीच्या. त्यातली कुठलीही मेथड, कुठली म्हणजे जी सुटेबल आहे, ती जी सुटेबल त्या प्रॉब्लेमला सूट होते त्या मेथडने करायचं. हा प्रॉब्लेम सबस्टिट्यूशनने नाही करता येणार. पहिले 3 सबस्टिट्यूशनने करता येत होते म्हणून सबस्टिट्यूशन केलं. How will you come to know whether this problem can be solved by substitution or it needs by parts or it needs partial fraction? No. There is no any criteria. You have to try. सरळ इंटिग्रेट करून पहा, प्लेन इंटिग्रेशन नाही होत. सबस्टिट्यूशन करायचा प्रयत्न करा, नाही होत. बाय पार्ट्स करून पहा, जमतंय, जमला. ठीक आहे. तर आपण पुढच्या लेक्चरमध्ये हा प्रॉब्लेम डिस्कस करू. तोपर्यंत नमस्कार.